The last thing we're going to do for today is talk about multiplication, but not multiplying matrices, multiplying by something that's called a scalar. And that's a really, really fancy looking letter or a fancy looking name that just basically means a number. It's just a number that multiplies into a matrix. So this number right here, you see it's multiplying inside the matrix, is a 3. That's called a scalar. All right, it's not super important that you memorize that word, but just know if you see the word scalar, you know what that means. He's just a regular number that multiplies a matrix on the outside. Now, if I tell you that matrices are very user-friendly, what do you think you should do with that 3? What's he going to do to the matrix? For me, when I see that, I feel like he's going to go inside and multiply every single entry. And you would be right. How nice is that? So that means we're going to get 3 times -2, 3 times the 0, 3 times the 4, and 3 times the -7. Shall we simplify that? All right. Square brackets here. How about -6, 0, 12, and -21? That's 3 times that matrix. That's all you have to do. Scalars are great too, because they just multiply into the matrix. All right, let's try this next one over here. Now, notice first of all, friends, that the -2 is a scalar. But I ask you a question, is the -2 multiplying the first matrix, the second matrix, or both? If you look literally on it, he's only attached to the left matrix. So the -2 is only going to multiply into that matrix. He's going to multiply all 6 terms on the inside, but he's not going to multiply the second matrix. Well, let's take it step by step, guys. Why don't we multiply the full first matrix by -2? Okay, that would make it -2 and 4, 0, and -6, 8, and -10. All right, so we multiplied the left matrix by the scalar. Now, we didn't do anything to the right matrix, so let's just rewrite him again. All right, well, look what we're doing now. We're going to be adding them together. So we should really do that check and see, are they the same dimensions before we do this? The one on the left is a 3 by 2, 3 rows and 2 columns. And the one on the right is also a 3 by 2. So can we add them? Yes, we can. Let's do it. Now, we're running out of room here, but we can do it. Let's take every corresponding entry and just add together. So -2 and -4, 4 and 5, 0 and 6, -6 and -8, 8 and -2, and -10 and 6. That is the final answer to this question. So look what we did. We did the scalar first. Think about order of operations. And then we took that answer and we added it to the matrix on the right. Hopefully that went okay. All right, why don't you pause and can you try examples 1, 2, and 3 below? Just basically write out what you see for each one. What does 3 times matrix A look like if matrix A is right up here? What would -b look like in number 2? And what would 3 times A minus B look like? All right, why don't you pause and try it, and we'll come back. All right, example number 1. We're doing here 3 times the matrix A, which is the 3 scalar multiplying the whole matrix A. Matrix A was 2, 2, 4, -3, 0, 1, and 2, 1, 2. All right, well, it's a scalar. The 3 can just multiply every single term. And we get 6, 6, 12, -9, 0, 3, and 6, 3, 6. Notice I don't have to really worry about dimensions or size here. I just multiply inside. And that's the answer for number 1. Number 2 says, can you find the negative of matrix B? Well, I'm going to rewrite it like this. I'm going to make negative really like -1 times B, which makes the -1 actually a scalar. Okay, here's matrix B. So we're just going to multiply inside by -1. Just be careful of all your negatives, friends. I should get -2, 0, 0, -1, 4, -3, and 1, -3, -2. Final answer for number 2. All right, and the last one. Number 3 is a little bit more complicated. Let's see what we have to do. This was 3 times the matrix A minus the matrix B. Okay, let's see. Let me rewrite that. That's the same thing as 3 times matrix A, which again was 2, 2, 4, negative 3, 0, 1, negative, and 2, 1, 2. And then I'm going to subtract the matrix B. Matrix B again was 2, 0, 0, 1, negative 4, 3, and negative 1, 3, 2. All right. By order of operations, folks, we really have to do this left one first. Let's multiply this by the scalar 3, and then we'll subtract our answers here. All right, so when I multiply the first matrix by 3, I get 6, 6, 12, negative 3, 0, negative 1. Oops, I didn't multiply yet. Mr. Brown, wake up. Sorry about that. I really meant to say negative 9, 0, negative 3, and 6, 3, 6. There we go. Now we're going to take that matrix and we're going to subtract the other matrix B that we didn't touch before. Now again, before we do this, since we're adding and subtracting, we really have to check what are the size and dimensions and do they match. The left one is a 3 by 3. The right one is also 3 by 3, so we may proceed. All right, well now, let's just rewrite it by doing all the corresponding entries and subtracting. Again, be careful with your negatives. So take all the corresponding entries. I'll start on the top left and start working my way to the right. So 6 minus 2, 6 minus 0, 12 minus 0. Second row, how about negative 9 minus 1? 0 minus a minus 4 becomes plus. Negative 3 minus 3. Okay, last row. How about 6 minus a negative 1? It's plus. How about 3 minus 3? That was nice. 6 minus 2. This is almost so easy that it's very, very, very easy to make little mistakes. So just be careful on your work. Now, is there a faster way we could have done this? Yes, absolutely. Do you notice that part 3, example 3 here, is basically just taking number 1, your answer, and number 2 and putting them together. So if you look at your answer for 1 and look at your answer for 2 and we add them together, you should actually get your answer for 3. But I like the way we did it the long way so you can see all the steps, and it worked out great. There's your basic intro to matrices, folks. Hope you like it so far, and good luck for the rest of the work module.